Hey everyone, welcome to 3.3 increasing and decreasing functions and also the first derivative test. Alright, so let's talk about definitions of increasing and decreasing functions. You probably know what they are, just as you go to the right, stuff moves up. But here's the official definition. A function f is increasing on an interval if, for any two numbers x1 and x2 on the interval, or in the interval, x1 is less than x2, that implies that f of x1 is less than f of x2, right? So if you have 2 points, we just have this point and this point. Here's x1, here's x2. The functions are just f of x1. The function values are lower for x1 than they are for x2. And similarly for decreasing, they just go down as you go from left to right. Okay, so in previous sections we found critical numbers. How did we find critical numbers? Well, if you remember, we found f prime of x, and we set it equal to 0, and then we solved for the derivative. Okay, good. So let's use that same idea to help us find when a function is increasing or decreasing. Then we can find minimum or maximums. Okay, so here's theorem 3.5. Let f be a function that is continuous on the closed interval a, b. Remember, continuous means that there's no holes in it, or asymptotes, and differential on the open interval a, b. So that means it's not going to be too pointy or anything like that. All right. So if f prime of x is greater than 0 for all x in that open interval, then f is increasing on the closed interval. All right. If f prime of x is less than 0 for all x in a, b, then f is decreasing. And if f prime equals 0 in all x in the open interval, then f is constant. Which, I mean, makes sense, right? If the derivative, aka the slope, is greater than 0, the slope is going to be positive, which means the whole thing's going to be increasing for this whole time, right? If the slope is negative, then it's going to be decreasing, right? Even if it's decreasing slower and slower, as long as it is less than 0, if it's really, really steep, or almost 0, it's still going to be decreasing, right? And if it equals 0, then the whole thing is going to be constant just because we're going horizontally. Okay, so I don't think any of that is really too challenging. It's nothing that you really haven't learned before. So let's do this example 1. Find the open intervals on which f of x equals x cubed minus 3x squared minus 3 halves x squared is increasing or decreasing. Alright, so let's do that first here, and then we're going to talk about interval, and we're going to do some of this other stuff, but let's do this first. So we want to find out where it's increasing or decreasing, so let's find the derivative. So let's find f prime of x. Well, f prime of x is going to equal 3x squared, right? And then minus 3 halves times 2 is going to just be 3x. So there's our derivative. So we're going to find out when is that equal to 0. So we say 0 equals 3x squared minus 3x. Well, they both have a 3x in them, so we can say 0 equals 3x, and we end up with x minus 1, right? So that means either this one is 0 or this one's 0. So it means 3x equals 0 or x minus 1 equals 0. So we get x equals 0 or x equals 1. So our intervals, we only have 2, right? We only have 2 numbers. So that means our intervals is going to go from negative infinity to our smallest one, and then we're going to go from 0 to 1, and then we're going to go from 1 to infinity. Alright? So we're going to be looking at these intervals right here. Okay? So that means I can pick a number anywhere in between negative infinity and 0. I can pick anything in between 0 and 1. I can pick anything in between 1 and infinity. So we can pick any number when we say test value, because what we're going to do is we're going to pick something that happens in between all these, right? And it should be all the same. It should either be increasing or decreasing. And we won't have missed anything because we know that the derivative is 0. There's only 2 times, which means there's only 2 times where it either does this or this, right? There's only this one and this one. So if we have anything in between that interval, I'm not missing any sort of critical numbers because it's not the slope is not going to be 0 anywhere in between those two. So the slope is not going to be 0 in between here, so it's all should be the same. If it's positive for a while and negative for a while, that means we must have gotten a 0 somewhere in the middle because it's differentiable using MVT, or Raleigh's theorem. So therefore, we're not going to miss anything. So we need a test value. Can you pick whatever you want? Sure. I'm going to pick negative 1. For this one, as long as you don't pick 0 or 1, we can pick anything that we want. I'm going to pick 1/2, and I'm going to pick 2. Alright, so those are the numbers. I chose them because I wanted to. So what's the sign of f prime? So what I'm going to do is I'm going to, instead of setting it equal to 0, now I'm going to take this -1, plug it in, take that 1/2, plug it in, take the 2, and plug it into this equation right here. We don't want to set it equal to 0. I want to find out what is the value of f prime. Alright? Alright, so I don't have quite enough room on here, so I'm just going to kind of cover this stuff up and say, let's start off from here. So I want to be able to say, what is f prime at -1? Well, that's going to equal 3 times -1 squared minus 3 times -1, right? So f prime of -1, that's going to be 1 times 3 minus -3, which is going to be plus 3, which is 6. So that means f prime at -1 is greater than 0. So sign of f prime is going to be positive. Alright, so let's try the next one. Let's do it right here. F prime of 1/2. So is going to be 3 times 1/2 squared, which is 1/4, minus 3 times 1/2. Right? So 3 times 1/4 is 3/2, or 3/4 minus 3/2, and that is going to be negative, right? 0.75 minus 1.5 is a negative. So the sign of this one is negative. And then between 1 and infinity, so that means we're going to have, let's move this up here just for a second, f prime of 1 is going to equal 3 times 1 squared minus 3 times 1. So 3 times 1, wait, I can't use 1. Why am I using 1? I shouldn't have used 1. I should have used 2, the number that I actually chose. So let's try f prime of 2 equals 3 times 4 minus 3 times 2. So that's going to be 12 minus 6, which is positive. So that means this number is positive. So that tells me that I know my function is increasing, decreasing, and increasing. Let's just check this out real quick on Desmos. So here are my critical numbers, 0 and 1, which we found. My function is increasing, decreasing, increasing. Oh, that's exactly what I said here, right? It's increasing, decreasing, increasing. So what does that mean for my conclusion? Exactly what we just said. It's increasing, it's decreasing, and increasing. So there we go. Okay, so find the open intervals. From negative infinity to 0, my function is increasing. From 0 to 1, it's decreasing. From 1 to infinity, it's increasing. And there you go. That's what we're looking for. Okay, so here's what I'd like you to do next. Check the guidelines for finding intervals for increasing and decreasing functions on page 170 in the gray box. Alright, they should be there. Make sure you get those. Make sure you know them, because it's going to be important that you can figure those out. Okay, next, let's do the first derivative test. This is going to be a pretty important thing that will show up on the free response questions on the AP test. And it's going to be kind of a little subtle thing, so you really have to know it now, because they're going to say, oh, you should be able to find this. And really they're saying, use the first derivative test to find this one thing to find something else. Alright, so the first derivative test says, if we can find when f is increasing and decreasing, then we will define the maximums and minimums, right? If we go back to here, we know it's increasing to decreasing to increasing. We knew this is a relative maximum, here is a relative minimum, right? Those are our relative max and relative min. Sure, totally makes sense. Okay, so we're going to try and use the first derivative test because it really does that kind of stuff for us, alright? So this is the theorem 3.6. This is the first derivative test. It says, let C be a critical number, aka the derivative is equal to 0 or undefined, of a function f that is continuous. Now this is an important thing. So if we want to be able to use the first derivative test, you might have to show a function is first continuous on an open interval I containing C. Alright, if f is differentiable, so we also probably have to check for differentiability on the interval, except possibly at C, then f of C can be classified as follows. 1. If f prime changes from negative to positive at C, then f of C is a relative minimum. And if f prime changes from positive to negative at C, then f of C is a relative maximum, right? So if we look at our last example here, let's just get rid of this here real quick, we know it's increasing to decreasing gives us a maximum, right? And that's exactly what we said for the first part. If it goes from negative to a positive around C, right? If f prime changes from negative, then we have a relative minimum. Sorry, I was actually looking at number 2. It goes from a positive to a negative. We're increasing, decreasing, it's a max. Then we have decreasing to increasing, this is a minimum, all right? Really, that's the idea, because if you think about the slope right here, there would be my slope, and right here, here would be my slope. So my f prime is decreasing, my f prime is increasing, and here is a minimum. Here, my f prime is positive. Here, my f prime is negative. This one is a maximum, right? Here, f prime is increasing, and this f prime is increasing. This is neither. So we do need to make sure that f prime has to switch from a positive to a negative. Otherwise, you don't get a maximum or min, or you get something else that we'll talk about later. All right, so this one is decreasing, and this one is also decreasing. So we got a negative and a negative. So this point right here is also neither, because those derivatives, the slopes, do not switch from positive to negative. All right, good. Then let's do this example. Find the relative extrema of the function f of x equals 1/2 x minus sine x on the interval 0 to 2 pi. So we are kind of containing this one. So let's look at this graph. We're looking at this one right here, and we're looking at from 0 to 2 pi. All right, I'm going to go zoom out just a little bit. There we go, 0 to 2 pi. So here's 0, here's 2 pi approximately. All right, so we're looking at this, being able to use a calculator. Great, we can use this kind of stuff to figure out exactly what we want. Now let's just kind of see if we can find where the relative extrema would be with our calculator, and then we can verify that's true with the manipulations by hand. Alright, so what we're going to do is, let's just take a look. Where do you think this is going to be? Well, I would bet my slope of 0 is probably right about here, and slope of 0 is probably right about here. So we're looking at these two numbers, and if we check those out, what do you think those are going to be in terms of radians? And I've set this up to be pi over 3, and this one is 2 pi over 3, 3 pi over 3, 4 pi over 3, and this will be 5 pi over 3. Alright, so we've got pi over 3 and we've got 5 pi over 3. Probably where my critical numbers are going to be, and it looks like this one's going to be a minimum, it looks like this one's going to be a maximum. Alright, so we should be able to kind of find that out, because it looks like this is decreasing, then my function's increasing, then it's decreasing again. Alright, so my slopes are negative to positive to negative. So it looks like we're kind of switching spots. In this one, well, looks like it kind of changes some stuff. We don't really worry about what happens at pi. Alright, so let's go back and work this out by hand. Alright, so what we're going to have to do here is we have to take the derivative, right? So we're going to say f prime of x is going to equal, what's the derivative of 1/2 x? Is going to be just 1/2. And what's the derivative of minus sine? It should be minus cosine x, right? Okay, then we set this equal to 0, and you say 1/2 minus cosine x. We took the cosine to the other side, we say cosine x equals 1/2. Now we have a whole bunch of values where that could happen, but when does cosine x equal 1/2 on the interval from 0 to 2 pi? And that is at, that's right, pi over 3 and 5 pi over 3. So there's our two values, okay? So now what we're going to do is let's look at our interval. Well, our interval starts at 0 and then goes to pi over 3, right? And then we go pi over 3 to 5 pi over 3. That's not quite 2 pi, all right? And then we go 5 pi over 3 to 2 pi. All right, so we're looking at these open intervals, all right? So there we have it. So now we want a test value. So pick a number that's between 0 and pi over 3. Well, pi over 2 doesn't work, but let's pick pi over 4. That's kind of a weird way of writing it. I don't have a lot of room here. So that would work. Okay, pi over 3 and 5 pi over 3. Well, 3 pi over 3 would be 1 pi, so pi would be in between there. That's a really nice one. And then 5 pi over 3 and 2 pi. If you're looking at your unit circle, which I am, we can pick 7 pi over 4 or 11 pi over 6. I'm going to pick 7 pi over 4. All right, I just use my unit circle to pick some of these numbers. So this is pi over 4, just pi, and 7 pi over 4. So let's find the sign of f prime, which means we're going to pick these values and we're going to put them back in to our original function, right? Our original derivative before we set it equal to 0. All right, so pi over 4. So we have 1/2 minus cosine pi over 4. Well, cosine of pi over 4 is going to be the square root of 2 over 2. So it's 1/2 minus square root 2 over 2. Well, square root of 2 is bigger than 1, so that means this one is going to be a negative. All right, if I plug in pi, 1/2 minus cosine pi. Cosine of pi is 0. 1/2 minus 0 is going to be 1/2, so that is a positive. And then 7 pi over 4 is also going to be square root of 2 over 2, so this one should be the exact same as pi over 4. So that also should be a negative. So it's decreasing, increasing, decreasing, increasing, and decreasing again. Alright, so that means, what does that tell you? I'm decreasing and increasing, so that means this is going to be a minimum, and this is going to be a maximum, right? Because these things are switching signs. So my minimum decreasing, maximum right here. So minimum at pi over 3, maximum at 5 pi over 3. And let's look, is that what we said? Minimum at pi over 3? Yep. Maximum at 5 pi over 3? Yep. Okay, that means we got that one right. Alright, so I think we'll do this example 3 just for a different example, and then we will keep going in a little bit. Oh no, I need to pause this.